Hello everybody. Today we are going to be looking at the question paper grade 11 wrote as their June exam. So without wasting time, let's talk about what they have written. This paper was very easy. I think you know that very well, that this paper was very easy. Let's go through maybe within 30 minutes. The paper can be done. All right. Let's start with the first question. The first question is saying that the intermolecular forces of attraction, holding the molecules of ice. When you talk about molecules of ice, it means that you're talking about H2O. Don't forget that H2O is like that. Sorry. Yeah. And then another H2O like that, meaning that this hydrogen is going to be like that. So this bond is called a hydrogen bond. So we have to look for hydrogen bond. So the answer becomes that. They're saying that in which of the following is the tendency for ionic bond between the particles in the crystal lattice strongest? So here, when you look at, you have to look at what forms. When you say ionic, it means that you are looking at what forms between the metal and the non-metal. So when you look at this is a non-metal, 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 metal, and non-metal. So this one becomes the answer. So the two answers, 2 marks goes there. They're saying that which one of the following molecules contain polar bonds but is classified as a non-polar? When talk about polar bonds, it means that they have different electronegativity. Yeah, they have different electronegativity. So when you look at this, they are saying that but is classified as non-polar. When you look at this, it is different electronegativity, these bonds. But the force on this side and the force on this side is equal. Therefore, the answer is going to be 0 at the end of the day. These two, they have the same electronegativity. So this one can't be. This one, they have different electronegativities. So at the end of the day, it's going to be polar. So because this side, I don't have anything, and it can't be because this one only for group 4. So this is also wrong. This one, the force this side and the force this side is the same. Unfortunately, this does not form a linear form or a linear structure. Look. So it has electrons, yeah, which makes it to be angular. So because of that, it makes this to be polar. Hence, the answer becomes this one is linear. So this force this side and this force this side is the same. Therefore, it becomes the bonds are polar, but the whole structure, because of the net 0 electronegativity, then the answer becomes A. So the 2 marks are supposed to be there. Which one of the following is non-hydrogen bonding occur between the molecules? Hydrogen bonds occur in molecules which are highly electronegative. If you look at this, is highly electronegative, is highly electronegative, is highly electronegative. This one is electronegative, but not that much. Hence, this is going to form hydrogen bonds. This one is also going to form hydrogen bonds. This one is going to also form hydrogen bonds. So the most correct answer becomes that. So B becomes the answer. Then when we go to question 2, they are saying that learners study the fluorine and the carbon bond at the that atoms of each can form with other atoms. Okay. They're saying that write down the number of valence electrons. Now, here, there is a difference between valence electrons, as I explained yesterday when I was giving you the prediction. There is a difference between valence electrons and the valence of the atom. So in this case, when you look at this is found in group 7. Therefore, the electrons which are found on outermost shell, the valence shell, is 7. Hence, the answer there is 7, and then this one is found in group 4. There are 4. But when you talk about the valence, because here they're saying valence, the number of valence electron, yes. But if they are talking about the valence of fluoride, it is going to become -1 because it is only remaining with 1 to become what? Become full. Yes. So I think you got it right. Define the term covalent bond. When you talk about covalent bond, I talked about it yesterday, that covalent bond is a type of bond which involves with the sharing of electrons. The electrons must be shared. Don't forget that is the transfer. There is also sharing. When you talk about sharing, then you're talking about the covalent bond. When you talk about transfer of electron between a metal and non-metal, then you're talking about the ionic bond, or what you call electrovalent bond. Anyway, the answer, we have got the definition. Write down, I told you about the definitions yesterday. Anyway, let's go to the next one. Write down the Lewis structure for fluorine and the hydrogen cyanide. This was our food yesterday, hydrogen cyanide. Okay, fluorine is in group 7. Ne? If it's in group 7, it has 7 electrons. So times 2 because I have 2 of them. So it means that the electrons I'm supposed to use, they're supposed to be 14. So now I'm going to draw fluorine. Yes, it's 1, it's 2, it's 3, it's 4, it's 5, it's 6, it's 7. Then other side also, it's 1, it's 2, it's 3, it's 4, it's 5, it's 6, it's 7. Meaning that now this one is going to form in the bonding. Hence, that is the structure. And then when you go to hydrogen cyanide, you're going to be carbon is 1, is 2, is 3, is 4. And then hydrogen is 1. And then what about nitrogen is in group what? Find out with group 5. 1, 2, 3, 4, 5. It means that now this and this and this, they're going to form a bond. Hence, the structure is going to look like hydrogen bond. Yes. And then you have carbon. This one is not there. Sorry. And then carbon, 3 of them. And then nitrogen, also 3 of them. And then nitrogen has a lone pair. So basically the structure going to look like that. Then when you go to write down the name of the bond, the type of bond between particles in the molecules, they're saying that write down the name of, here they're saying the bond of type of bond between particles in the molecules. Particles in the molecules, not between the molecules. They're saying particles in the molecule, meaning that they're looking for the bond between, how do you call that bond? How do you call that bond? And how do you call that bond? Basically, these are as a result of sharing. Hence, they are going to be covalent bond, and they are formed by sharing of electrons. So they're saying that on the periodic table, the electronegativity of this for oxygen and this for nitrogen. Define electronegativity. So here we have different definitions depending on, but basically electronegativity is the ability of the atom to pull the bonding pair of electrons toward itself. I gave you an example of hydrogen chloride yesterday, and then I said that it's not shared equally. So because this one has ability to pull the bonding pair of electrons toward itself, that ability is what you call electronegativity. And I gave an example of saying father and mother, who loves money most. And I say that people were saying that mother loves money most. Therefore, the electrons, the money is pulled to the side of the mother. Yeah, so basically that is the power of this atom to pull the bonding pair of electrons toward itself, is what you call the electronegativity. Then we go to explain why oxygen is more electronegative than nitrogen. If you look at oxygen, oxygen is in group what? Oxygen is in group 6, while nitrogen is in group 5, if you go to the periodic table. Meaning that oxygen will have, don't forget that it has those 2 electrons from the first shell. So it means that this one is going to have how many protons? 7, if you go to the periodic table. And then this one is going to have how many protons? 8. So because the protons will pull the electrons, yes, because protons are positive, therefore we're going to say that oxygen has 8 protons, which pull the electrons more than, yes, nitrogen, which has 7 electrons. Hence, the electronegativity of oxygen is more than the electronegativity of nitrogen. Guys, don't forget that we are going to be having different classes about this physical science, because we found out that grade 10 and grade 11, they're also struggling in this subject. Therefore, please keep in touch with Thundereduc. After this, we'll be launching for grade 10. We go through what they talked, what they wrote. And then tomorrow, we will talk about grade 12. So you can tell your sister, your brother, your friend, share the YouTube channel so that everyone can benefit from this. Q is saying that Mr. Saidi always has the best prediction. Thank you. You are welcome. Yeah, we'll always give you predictions. We'll always give you predictions. Yours, term 3, your term 4. We want to look for distinctions in science, because we know that the science is always having a problem in students. Anyway, let's go to the next question. They're saying that define bond energy. Basically, when you talk about bond energy, we have different definitions depending on what your teachers taught you. But in actual sense, bond energy is the measure of the bond strength. Meaning that if the bond energy is high, it means that the strength of that bond is going to be what? Is going to be also high. So sometimes we define bond energy in terms of the amount of energy being released when 1 mole of bond is being broken in gaseous form, and this type of bond must be in a covalent state. So you can also define it in that way. So it depends on what your teacher has taught you, but as long as you define it correctly, then you get your 2 marks. Then you're saying that write down the relationship between bond length and bond energy. When you talk about bond length, here, when I was teaching this, I gave students examples of chalk. And then I said that you have a long chalk, you have a short chalk. Then I asked 2 students, said that break. Then they were able to break this, and we were not able to break this. Anyway, this means that the longer the bond, the weaker it is, and the shorter the bond, the stronger it is. So when you say bond length and bond energy, it means that when the bonds are long, the energy is going to be less. And when the bonds are short, then the energy is going to be more, meaning that it's going to have a higher bond energy. Is it clear? And then they're saying that which one of the following A, B, C will have the weakest, will be the weakest. In this case, explain. This one is going to be the weakest. Why? It's long. How do I know that it's long? Because we know that some of the factors which affect this, we say that the bond order. Bond order. When you talk about order, it means that how many bonds are they? Atoms with 1 bond or single bond, they have longer bonds and these bonds are weaker compared to atoms which have multiple bonds or double bonds. So it means that this one is weaker than this one is weaker than this. Hence, you're going to say that which one is the weakest is A. So the answer must be A. And why? Because it is single bond. It is single bond. That's it. So we go to the next question, the last one. But this paper was good, ne? Was really good. And those people who did our prediction, I think now you are happy. All right. State whether each of the following molecule is polar or non-polar. When you talk about polar or non-polar, first identify whether this molecule does not have any lone pairs. If it has lone pairs, the chances are high that that molecule is going to be polar. But if it doesn't have lone pairs, then it means that there will be equal distribution of these bonds. Anyway, let's go to ammonia. Ammonia, I emphasized about this ammonia yesterday. Anyway, ammonia is going to be, so why do we know? Why am I drawing this? I'm just going to draw just the structure so that you see that, because they don't want this. They want to say polar or non-polar. Because these ones are not equally distributed. If this was here and this lone pair was not there, then it would have been non-polar. But because of this, these bonds are not equally distributed. And you have also this side. Yes. So, and this electronegativity is too much. Hence, this molecule is polar. That's why ammonia can dissolve in water. And then this one is tetrachloromethane or carbon tetrachloride is the same thing. Tetrachloromethane or carbon tetrachloride is the same thing. So, because now carbon is like this, and the carbon doesn't have lone pairs in this regard. So, look, the force this side and the force this side is equal to the force this side and the force this side. Hence, it's going to be non-polar. So, this one is polar, and then this one is non-polar. Then we go to the next question. Which type of intermolecular forces between particles? How do you call? Okay. Which forces of attraction do we find in ammonia? Which force of attraction do we find in ammonia? Water, I talked about it. We always find hydrogen bond. Wait. Intermolecular force. They're not saying in the particles of ammonia. No. They are saying the between ammonia and ammonia. Because this question is different from this question. You see, this question. Because here they say that the type of bond between the particles in the molecule. Meaning that they're looking for this. While here, they're saying intermolecular. They didn't say intramolecular. Because if they said intramolecular, then they are talking about hydrogen. No. They're talking about covalent bond. But here they're talking about ammonia, one ammonia and another ammonia, hence is hydrogen bonds. Then we go to, this is sodium, which is group 1, and then this is chlorine, which is highly electronegative, because a solid and a metal and a non-metal, therefore is going to form ionic dipole. And then this liquid hydrogen, helium, because this one is a non-metal, doesn't form strong bonds with each other. That's why it's always a gas. Therefore, is a London forces or London depression. And then they are saying that this is a hydrogen with the electronegative. It will be highly electronegative, another non-metal and non-metal with a electronegative, therefore is going to form dipole forces. Yes. So I think I'm done with that question. They're saying that water evaporates slowly than carbon tetrachloride or tetrachloromethane. Explain this statement. We saw that this carbon tetrachloride is a non-polar, while water is a what? Is a polar. So this one forms hydrogen bonds. So because it forms hydrogen bonds, yes, Yes, because it forms this one. This one does not form hydrogen bonds. It forms dipole forces. And we say that hydrogen bonds are stronger than dipole forces. Hence, this water will require more heat to be evaporated compared to tetrachloromethane or carbon tetrachloride. This one is because of the intermolecular forces, which is hydrogen bonds, while this one is dipole forces. Hence, this one will require hydrogen bonds are stronger than dipole forces. This one will require more heat to evaporate compared to this. And then the last question, melting point. When we talk about melting point, they're not asking what is melting. They're asking melting point. The point at which the solid state, the point at which the solid melts is called melting point. Then they're asking identify the dependent variable, independent variable, dependent variable, independent ID. Yes, independent variable, dependent variable. Is it true? Do you think so? Anyway, dependent variable is the melting point, meaning that basically the temperature at which this substance is going to melt. Then, independent variable is these alkanes. So, which alkane? All of them are alkanes. So, this one will, this temperature will depend on the type of alkane. Write down, so this is independent, this is dependent, ID. They are saying that write down investigative question here, depends on how you have designed it, but they are looking at how does these carbon atoms in alkane affect the melting point. Basically, how does this mass affect? Increase in mass. How does increase in mass affect the melting point? Yes. So it depends on how you have phrased it. And then we'll explain why this wax has the highest melting point. Here there are two reasons you can use, or you can use one reason, is because of the highest mass. Higher the mass, the higher the London forces. London forces, meaning that it will require high amount of heat to break those London forces. Or you can say that as the number of carbon atom increase, yes, the number is the same thing as mass, but as the number of carbon atom increase, the melting point also increases. Therefore, this one has the highest number of carbon atoms. Hence, the melting point is high due to the London forces increasing. I think that was the paper. I didn't see why did they put this this formula sheet. Why did they put them there? Did we use the periodic table? I think we used the periodic table, but the formula sheet was not necessary for this exam. I think that was the paper. I expected you to have a distinction. If you have not got a distinction now, let's try to target for the next exam, that is September, and then we are able to get those distinction. Thank you very much. It has been M.Saidi to take you through. I wrote well. Thank you, sir. Tulufero Maseko. Thank you very much, Tulufero Maseko. And I wish you the best in you guys, whatever you are doing. I know that we're going to have more doctors and we're going to have more nurses. We're going to have a lot of them who are scientists. God bless you. M.Saidi, as usual.